Hi, I will cover today concrete columns. Um, I think that it will be pretty useful, especially for students who are taking concrete design class. Why? Because I will show you the three different type of column sections, and I will go step by step into procedure how we can use interaction curves for different type of cases regarding to columns. So firstly, let's talk about what is column. Column is a vertical structural member which support axial compressive loads, and we can or we don't have moments. So it can be pure loading or it can be bending loading, or it can be biaxial loading. So the cross sections of the column usually are considered as very low in comparison to their height, and column will support vertical loads from the floors and roofs, and it will transfer down into foundation. So how we can divide the columns? There are different types of column. Firstly, based on shape, we are talking about rectangular or square columns, and we have circular columns. And the second type will be based on reinforcement details. So we are talking about tie structure or a spiral type of reinforcement. So this is the example of square and rectangle cross section. And we have here secondary steel or stirrups or tie rebar ring. Usually in countries where earthquakes occur, we have the distance or spacing between secondary steel to be 15 centimeters or 6 inch. And if there is country without earthquakes, they have a different rules. This is the example of square cross section. This is example of rectangular cross section, and we have circular shape with spiral secondary steel. So it will be circular like this, and we need to determine the spacing or pitch distance. So in comparison to beams, columns has whole columns needs to have even number of main rebars, and they needs to be symmetrical. So for the beams, we said we have or we don't have rebars in compression zone, but we will have in tension region. So three types of column design. Firstly, if column is only subjected to axial load at center, then we have columns subjected to combination of axial and bending moment. And the third type, when we have columns subjected to combine axial and biaxial bending. So first case, we have pure axial load at center. So column is subjected only to compression zone, compression force, and we need to think only about slenderness in this case. The second type, we have a force and we have some eccentricity from the center, which means we will have a moment P times eccentricity, and we have force also. And the third type, we have force, two beams, two eccentricities, one in x direction, the second in y direction, which means we will have two type of moments, mx and my. And also we will have axial load at center. So let's talk about first case. In first case, we need to determine ultimate load, and that equation is given to us in ACI code. So according to ACI code, in this equation, we will have gross area of column, then we have steel area, we have Pn naught, which will be nominal strength, and we have K3, which is coefficient or 0.85. And according to this, our design philosophy will be that axial load or capacity of the force has to be equal or higher than external force PU. So in this case, we will have, according to ACI code, code VPN max to be 0.8, VPN not, and for tie column, this phi is 0.65. For circular column, we have this phi to be 0.75. So spiral columns has equation VPN max to be 0.85 times 0.75 times 0.85 compressive strength of concrete. Then we have gross area of column, still area of column plus yielding stress times still area of column. For tied columns, it will be 0.8. Here, instead of E, 0.65. Then again, we have 0.85 compressive strength of concrete, gross area of column, still area of column, yielding stress, and still area. Regarding to spacing, we can say that we are using again ACI code, and spacing for ties will be 16 dB, which is a diameter for main rebars, 48 dB, which is the secondary diameter for a secondary steel, and we have width of the column. And bar selection, if we have number 3, number 10 for the main rebars or small, we will use number 3 for tie. And if we have main rebars higher than 11, then we are going with number 4 for tie. Spiral reinforcement, in this case, we will use ACI equation for reinforcement ratio. So again, this is spacing between tie, 48 times diameter of tie rebar, 16 times diameter of primary steel, and we have column width. So regarding to circular column with spiral reinforcement, we have equation that rho minimum has to be equal rho actual. This is reinforcement ratio, and that one is 0.45 FC prime. We are dividing by FU, multiplying with gross area of column by core area of column minus 1, and rho actual to be 4 times area of spiral rebar used for loop. This is core diameter minus diameter of spiral bar. Then we have a spacing, and this is core diameter. So what is the core diameter? That is this length. So the diameter of column minus 2 times concrete cover. I will do one example. We need to design a square tie column to support axial dead load, which is 166.6 kips. Then we have axial live load, which is 180 kips. And we are assuming 2% steel area of longitudinal steel. So in order for a rectangular or square column to be economical, steel area has to be between 1% and 3%. So FC prime compressive strength of concrete is given to be 4 KSI, yielding stress is 60 KSI, and we have total load to be 1.2 dead load plus 1.6 live load. So it will be 1.2 times 166.6 plus 1.6 times 180, which will give me the value of 488 kips. For tied column, we have PU to be VPN max, or 0.8 times 0.65 times 0.85. Compressive strength is 4. Then we have gross area of column minus area of steel plus yielding stress times area of steel. When we use, instead of area of steel, 0.02 gross area of column, and if we are plugging our numbers, we will obtain that 488 kips has to be equal or higher than 2.35 area gross. So in this case, we will obtain that area gross has to be higher than 207.07 inch square. Square root of this will give me B to be 14.38 inch, and we can use 4B 15-inch. So in this case, gross area will be 225-inch square. So still area will be 2% of this. So 0.02 times 225, that is 4.5-inch square. Using the rebar table, we can use 6 number 8 or 4 number 10. 6 number 8 is closer to 4.5, so we will go with this rebar distribution. So we need to design a tie. Again, for tie, we said the spacing of the tie, and we have 48 times. Since that it is number 8 rebars, we are assuming for tie to be number 3. So 48 times number 3 diameter is 0.375, that is 18-inch. Then we have 16 times main rebar, which is 1, that is 16, and the width of the column is 15. So we will go with 15-inch tie spacing. So we have number 3 ties at 15-inch spacing, and our drawing will be 15 by 15 concrete cover according to ACI code is 2.5-inch. So we will go with 6 main rebars, and this is our tie. So with this, we are going with in design philosophy, and I will do next example in the next video.